Hello DTech 2000. In this video, I will be introducing lookups in Excel. So let's go back to our data files folder and just open up simulated MN salaries. Make sure you save this as an XLSX file in the Unit 6 folder. So we're in Unit 6, choose XLSX, save. If you want to replace it, hit yes. If you want to keep what you have currently in that folder, I would recommend just giving the old file a different name if you want to keep it. But I'm just going to get rid of mine. So I have that saved now. The next thing I'm going to do is I'm going to go back to data files again and open up cities.csv. And let's save this file as an XLSX in the Unit 6 folder. That's done. So our goal is going to be, just like with what we did in R, to append the cities to the simulated MN salaries data frame. First things first, you need to make sure that both the simulated MN salaries and cities Excel worksheets are in the same workbook. The worksheet refers to a specific tab in Excel, and the workbook refers to the entirety of the file. So every Excel workbook contains multiple Excel worksheets. So here's how we do this. I'm going to take cities.xlsx, somewhere at the top, click and drag it. And I'm dragging it so that I can see both the simulated MN salaries worksheet and the cities.xlsx worksheet as well. Then here's what I'm going to do next. This is the cities worksheet. I'm going to click, hold, and drag this to the right of simulated MN salaries. Observe that black tick right there. That means that cities will be inserted as a worksheet to the right of the simulated MN salaries worksheet. I'm going to let go of my click. And now I have simulated MN salaries and cities in the same workbook. So remember, every workbook consists of worksheets. We have two worksheets in here, simulated MN salaries and cities. These are contained within the simulated MN salaries workbook. And a workbook is indicated by the fact that you have XLSX at the end of it. One thing you should know is that if you wanted to, you technically could reference external files in Excel workbook. That is, you could technically not drag cities into the simulated MN salaries Excel workbook. You could theoretically just keep them as their own separate workbooks. I do not recommend this for many reasons. I have dealt with the pain of referencing other workbooks within other workbooks. There are a multitude of things that could go wrong. For example, let's say that I'm referencing a workbook within another workbook. What's usually the case is that such workbooks could be contained in completely different folders. And if one day you just change the folder name of one of those workbooks, the Excel workbook that was originally referencing the other workbook for which the folder name has changed would just completely crash, because Excel is not smart enough to know, oh, you changed that folder name. That happens a lot. And generally speaking, I don't recommend referencing other workbooks within Excel documents, because if you move things around, they can just crash. If a file name changes, or if the file gets deleted, or if the file is moved, or even if the file's content changes and you're referencing this other file, the Excel workbook to which you are reading the external file's data will not pick up that it doesn't exist anymore, and it will just error out or provide inaccurate values or even crash. I've seen that. Another little story I'll let you know about too is that I once worked for a company where they were referencing external Excel workbooks within other Excel workbooks that were password protected. And in those situations, you wouldn't be able to access the other Excel workbook unless you knew the password for it. And because Excel does a terrible job of keeping track of what it is you did with an Excel document, let's just say that in one situation, the person who had the password had long retired and left the company. You're going to run into a lot of trouble in that situation. I have been in that situation. I do not want you to run into that situation. Long story short, I could talk about this for days. Just do not reference other Excel workbooks within a different Excel workbook. You are only asking for trouble in that situation. So let's talk about how to append the city values to the simulated MN salaries values. The one thing I want you to know is that without the use of fancy add-ins that you could throw onto Excel, Excel does not really have a way to do a join. Because here's the thing about doing joins in Excel. So I have simulated MN salaries right here. And let's say I wanted to append cities to this. The thing about things like R or SQL is that they work with things on a data frame basis. You could theoretically just take one data frame, join it to another, and then you'd have your appended cities to the right of this. Unfortunately, with Excel, everything is a cell-based operation. So you can't really do a join. You can try to mimic a join and maybe get the same output as a join, but the fact of the matter is Excel does not work with data frames as a whole. Excel works with cells. Every operation you do in Excel is a cell-based operation. It is not a data frame based operation. So whatever it is we do to try to mimic a join, we're probably going to have to do something among the entirety of cells in column F. So what had we done in dplyr? We had done inner joins, left joins, right joins, and full joins. And remember, the ID column is the column we were using to merge the two data sets. The easiest way to mimic a join is as follows. We're going to do something called a VLOOKUP or a vertical lookup. First of all, I'm going to add a city column header right there. And for this particular ID, we want to pull the city for it from the cities worksheet. How do we do this? We are going to do equals VLOOKUP. So this begins the VLOOKUP function. And what's kind of nice about Excel is that it gives you the arguments that you need for it. We need to start up with the lookup value. The lookup value is going to be the value that we're using to look up the corresponding value we want, which is, in fact, this ID. Let's press comma. Then the next thing we're going to do is we need to tell Excel what table we're using to get the value that we want to look up. That's the table array. So with our cursor after that comma right there, we're going to go to cities. And here's what I'm going to do. We are going to select the entirety of this table. I'm going to teach you a nice little trick in Excel for selecting all columns that have values in them. Make sure that cell A1 is selected, and then hold Shift and press right once. This will select the entire first row of this table. Then, what I want you to do is the following. I want you to hold Control, hold Shift, and then press down. This will select the entirety of that table without you having to hold your mouse through that whole thing. So your code should be cities, exclamation mark, A1 to B25001. This is referring to the fact that in the cities worksheet, you are selecting all cells from A1 to B25001. And for reasons I will explain later, please put $ before the letters and before the numbers of these cells as follows. A $ before the A, a $ before the 1, a $ before the B, and a $ before the 25,001. Let's press comma. And now what Excel is asking for is this column index number. What that's referring to is this. VLOOKUP will always assume that the identifier that you're looking up on is always in the first column. That makes sense. That's our ID column in column A right here. But then Excel wants to know, okay, you have your identifier in column 1. If you have a multi-column table, what value is it do you want me to output? In our situation, we want the output in column B, which is the second column of the cities table. So column index num will be 2, representing the fact that we want the final value from the second column. Then there's this additional argument that's optional called range lookup. I have never had any reason to only want approximate matches. I find that actually tends to get me into a lot of trouble. So for our purposes, we only want exact matches. We don't want Excel to try to approximately match our IDs when it is trying to look them up and find a corresponding city. So I'm going to type false in capital letters here. Let's type a parenthesis and press enter. So you can see now that for this particular ID, that Excel has generated the fact that this ID is from St. Louis Park according to the cities table. Now we need to extend this over the entirety of column F. How you do that, recall, is as follows. You see this green notch at the bottom right. I want you to just double click that green notch. And this will take a while. So now we have generated cities for every single ID where possible. NAs are going to appear if there's no corresponding match in the cities worksheet. So that is how you append city values to the simulated MN salaries table. So now that we've appended city values to simulated MN salaries, let's talk more about how to replicate the output of a join, given that we have finally appended the cities to simulated MN salaries. All you would simply do is this. Let's go to data and then filter. And remember, an inner join is just going to be whatever IDs exist in both simulated MN salaries as well as cities. The only way that would happen is if you managed to find an ID in simulated MN salaries that had a corresponding city. So all we need to do to replicate an inner join is, once we have done the VLOOKUP as we just did, we just have to filter for cities that are not NA. All I'm going to do is I'm going to scroll all the way down and deselect NA. So now you have there an inner join. If you wanted to replicate a left join, you would include the NAs as well. So this is the output you get if you do a left join. If you want to save this, you may. Another alternative, if you want to make it seem as if you know Excel really well, to VLOOKUP is index match. You can translate that VLOOKUP code we just did into an index match function, as you see here. I will let you do this on your own. The process is the exact same. You're just changing your formula, and you're going to throw index match where we had thrown VLOOKUP instead, and then you're just going to hit the notch on the bottom right and double click it and extend it through the entirety of all the cells in column F in this situation. People generally think that index match is faster. I don't really notice that in practice, personally. But if you really want to seem like you really know Excel, just tell your interviewer that you know index match. And if you can demonstrate how to translate between VLOOKUP and index match and that you understand how both of those work, you're going to know a lot more Excel than the average population. Here is another function that you should be aware of that was just released in July 2020. It is known as XLOOKUP. XLOOKUP is intended to replace VLOOKUP. I've gathered from the Excel community that there are concerns of backward compatibility. This is completely understandable because Excel is a proprietary product, and generally users of proprietary products are resistant to change. They like things that are stable when it comes to working with their software. So if you introduce a new function like XLOOKUP, people are going to be concerned about the fact that XLOOKUP is not going to be compatible easily with VLOOKUP, and they're going to have to spend the time to convert everything that's VLOOKUP to an XLOOKUP. However, I'm not of the opinion that you should be resistant to change when it comes to software or technology in general. Since you all are students who are currently in school, I think it is important for you to be aware of how software people are using in industry is changing. So I want you to be aware of XLOOKUP. Make sure you understand how it works and that you understand that it's just meant to be an update for VLOOKUP. And here's just the translation from VLOOKUP to XLOOKUP. One of the things you're going to observe here is as follows. With XLOOKUP, you still have the same cell for the lookup value, which is A2. However, with XLOOKUP, you specify what column is going to be where the corresponding ID will be in cities, which is column A. And then as the third argument, you specify where your final output is going to be, which is column B, which contain the city values that we seek. In VLOOKUP, the syntax is slightly different. You have to specify the entire table, and then you have to say, refer to column 2. Also with XLOOKUP, you have to throw a 0 at the end of it. I will let you do this on your own. Let's talk about right joins. Remember, the right join from cities to simulated MN salaries requires taking the corresponding ID values in cities and then sticking the simulated MN salaries data right next to it. I'm going to click on cities, and I notice that I'm nowhere near the top of cities. One nice little shortcut you can do for this is this. I just want to go back to cell A1, so I'm just going to type A1 up here and press enter, and now I'm at the top. So if I want to do a right join, I need to stick the following columns to the right of cities: the year, salary, sex, race, and city. I'm just going to copy those cells using Control C. Go to cities, Press Control V to paste. And then here's what we're going to do. We are going to do another VLOOKUP using this ID and getting corresponding year, salary, sex, race, and city value. So here's what we're going to do. We're going to do VLOOKUP A2, and for reasons I will explain later, please make sure that you put a $ before the A. I'll explain later why you should do this. Press the comma, and now we need to tell Excel what table to refer to. Go to Simulated MN Salaries, and I'm going to select cell A1, hold Control, hold Shift, press right, but do not let go of Control and Shift yet. Hold those, and then press down. So this selects the entirety of Simulated MN Salaries. And for reasons I'll again explain later, please put $ before the letters and the numbers. The first value we want is the year, which is column B, which is the second column. And we're going to use false for an exact match. Press enter. So it's pulled the year 2008. The column is going to need to change depending on what column we're in. Year in Simulated MN Salaries was in column 2. And then salaries in column 3, sexes in column 4, and races in column 5. We need to somehow take that into account when we are trying to extend this formula to the other columns here. So this 2 is only going to apply to this particular value right here, but it's not going to apply for columns D, E, F, or G. So here's how we can handle this. Instead of 2, I am going to do column -1. I'm going to press enter. And you'll see that still outputs 2008. Why does this column -1 make sense? It's because of this. In this particular cell, year is in the third column. In Simulated MN Salaries, year is in the second column. This column -1 is the corresponding year in this table, and so forth with salary, sex, race, and city. So what I can do then is I can extend this formula out to these other columns. I'm going to click and hold and drag this to the right. And you can see that it has generated corresponding salary, sex, race, and city values. Now I'm going to double click this notch, and it has extended those data all the way to the bottom of the cities table. But note the following. This is not a true right join. In fact, if you look at this, notice that it's only showing the 2008 values, which are the first matches in Simulated MN Salaries. Observe that for every ID, the first year that appears is the 2008 record. So this is not a pure right join. It only outputs the first rows for every corresponding ID. So this isn't a true right join. Only the first match appears. If you wanted to use index match instead, you can use this code right here. For full joins, don't even try to do those in Excel. Now, the last thing I want to describe to you in Excel is the idea of a relative reference. Relative references, I've actually been using those throughout this video so far. Relative references occur when you are using these $ before the cell column letter or the row number. And it might be a little confusing to understand why I'm doing this, and I'll explain these in a second. To demonstrate, what I'm going to do is I'm going to create a new worksheet. So I'm going to just throw in cell A1 a value such as 5. And then I'm going to put in values 6, 7, and 8 here. In this cell right here, I'm going to just do equals A1 and press enter. So that gives me this value 5. And if I wanted to, I could click, hold, and drag to get the cell on the right. I can click, hold, and drag to get one row down. So these two tables match. What is happening here when I'm playing around with this notch on the bottom right of every cell? Well, this is cell A1. Here's what is happening when I go from this cell to this cell. I'm shifting one column. So because this is A1, if I were to click, hold, and drag to the right, it would take A1 and shift it to the right by one column. So what was A1 here is now B1 here. And similarly, if I took this cell B1, I click, held, and drag down, the one change that is happening there is I'm still in the same column, but I am changing my row by 1. So what was B1 here is now B2 here. You need to understand what I'm doing here so that you understand how Excel links cells together. So this is a pretty simple concept. Basically, you're just starting with one initial formula and you're just dragging it around, and as rows or columns or both change, Excel will adjust the formula appropriately. Now let's consider the following. I'm going to make one small little change to this. I'm going to throw a $ right before the A. So the only thing that has changed is this 5 is now based on $A1 rather than A1. What is this telling me? If I drag out this formula to any other cell, this $sign is saying fix the column. What do I mean by this? Well, with this formula here, the $A1, what it does is it fixes the column. So when you would expect a column to change, the column will remain fixed. For example, in the prior example, if I had click held and dragged this to the right and I let go, this value right here would have originally been cell B1 because you're changing the column by 1 from what was formerly A1 with the 5. But now, with the $sign fixing the column, this value here is now going to be a 5. The reason why that's happening is this. I made a change of columns from this cell to this cell. And by using $A1, even though I made a change to the cell is going to remain fixed if I extend this formula out to a new column. So that is why this is 5, because I started off with the formula $A1, which fixes the column. And if I were to drag this out so that the column changed, this would also be 5, because the column is fixed based on the fact that there's a $sign right before the column letter. If I decided to take this formula $A1 now in cell C4, click held and dragged it down 1 row, the column does not change, but the row does change. So this $A1 should be $A2 when we drag it down, which is exactly what we see here. So the $sign, in other words, is inserted either before the row or column. It tells Excel fix the row or fix the column as you extend formulas to other cells. So this is known as a relative reference, which fixes the row. So now going back to this, let's just call this A1 all over again without the $signs. I'm just going to delete these old values so that I don't confuse you. Let's now put a $sign before the 1. So this is still referring to cell A1 right here. But now, because the $sign is before the row number, it's telling Excel, please fix the row number as the row changes. If I were to click, hold, and drag this down 1 row, that would be changing the row from 4 to 5. But because the $sign is fixing the row, that 1 will still remain the same as the row is being changed. What would have originally been A2 right here is now $1 because we have forced the row to be fixed as this formula gets extended to new rows. If I were to click, hold, and drag this to the right, the row remains the same. So the $sign doesn't really do anything here, but the column changes. So I would expect that whatever is in this new cell should be $1, which is exactly what that is. So in other words, just make sure you understand that how relative references work is depending on whether you throw the $sign before the column name or before the number, that it's either going to fix the row or fix the column depending on how you extend an Excel formula. You could, if you wanted to as well, choose to extend both the column and the row. I'm going to press enter. So this is saying now, no matter what row or what column I extend this to, keep the row and the column fixed. So if I were to drag this to any column or any row, I would always just have the cell A1 because I'm fixing both the column and the row number as I extend that formula. So that is how relative references work. So going back, we had done this VLOOKUP right here. What this code is saying is as follows. So we had taken this formula, we had extended it throughout every column in this row. We started off by putting $A2 right here. So this is saying the following. Because I'm taking this formula and I'm extending it throughout columns, I'm keeping the column fixed. Why do I want to do that? Because column A always has my lookup value, and I want that to be consistent no matter what column I'm in. So that is why I threw a $sign in front of the A, because I want the fact that the lookup value, the ID, is in column A to remain fixed. I don't want the 2 to remain fixed, because I want that to change depending on what row I'm in. It should be A3 in row 3, A4 in row 4, and so forth. Next, I used fixed rows and fixed columns for the simulated MN salaries table. The reason why is this. If I didn't stick those dollar signs on there, they would be changing depending on the cell that I had the formula in as I extended the formula. I don't want that to happen. The simulated MN salaries table will always have the same cells no matter what cell I'm in the cities table. So that's why I chose to put fixed rows and fixed columns for referring to the simulated MN salaries table, because I do not want these values to change depending on what cell I'm in. The simulated MN salaries will always be from A1 to F 719,993. So that is why you need relative references. I am not going to cover ODBC connections in Excel. I really hope that you're never in a situation where you have to use Excel to connect to a SQL database. But if you ever find yourself in a situation where you are, you can use these slides to learn how to connect Excel to our SQL database for DSI 2000. And that's all I have for you.